So imagine you're building a $10 billion power plant, right?
Oh, wow. Okay, big scale.
Yeah, massive. You get like 99% of the way through construction, and you end up in this multi-million-dollar lawsuit over uh, zip ties?
Zip ties.
Zip ties, electrical tape, maybe a few extra feet of wire. I mean, it sounds completely absurd.
Right.
Because when you look at a mega construction site, the cranes touching the sky, the miles of steel, thousands of workers, you'd naturally think the big money is lost or made on the massive, highly visible things.
Sure, the concrete, the turbine.
Exactly. But in reality, in this high-stakes world of global infrastructure, the smallest consumable, like literally a 50-cent piece of plastic, can absolutely bankrupt a contractor.
It actually happens far more often than people outside the industry would ever realize.
Really?
Oh, absolutely.
Yeah.
Because you can't just hand someone a blank check for a massive industrial facility and say, hey, build it and send me the receipts.
Yeah, that would be a nightmare.
The financial risk to the developers and the banks funding these projects, it would be apocalyptic. So the entire construction industry relies on this underlying contractual structure that is just as heavily engineered as the physical plant itself.
And decoding that hidden structure is basically the mission of our deep dive today.
I love it. Let's do it.
We are exploring a stack of very specific, highly detailed construction documents. We're looking at excerpts from the FIDIC Red Book unit rate schedules, and specifically, we're focusing on the pricing preambles for the electrical and instrumentation aspects of a project.
E&I, as it's called.
Right, E&I. Our goal here for you listening is to figure out how contractors are forced to translate raw materials, like these massive high-voltage cables and hyper-delicate fiber optics, into a foolproof billing matrix, a matrix that theoretically prevents those zip tie lawsuits.
Yeah, the FIDIC Red Book is essentially, it's the gold standard for international construction contracts. It's the DNA of how work is actually measured, categorized, and most importantly, paid for across the globe. So what we are really looking at in these sources aren't just lists of prices. We're exploring the rigid legal boundaries of what a price actually guarantees. And to understand that, you really have to look at how the developers shift the risk of almost every microscopic detail onto the people actually doing the building.
Okay, let's unpack this. Because before we can even get into the physical wires and the high-tech instruments, we have to understand the language this contract speaks.
Right.
The sources we have keep referring to the WBS, or the work breakdown structure. And I got to be honest, when I first looked at this, it just looked like a wall of random numbers.
It does look like that at first glance, yeah.
So how detailed are these codes? Are we just talking like big wire versus small wire here?
Oh, no. It is incredibly granular. The WBS code system is, it's a mechanism designed to take an unmanageable, chaotic mega project and slice it down into these perfectly categorized microtasks.
Okay, so how does it work?
It starts up at level 0, which simply defines the project type. So, say, an upstream oil and gas facility, or maybe a midstream processing plant.
Right, the big picture.
Exactly. But then it cascades down, level by level. By the time you get to level 4 or level 5, you are specifying electrical, instrumentation, and telecom.
Okay, got it.
And then it drops further. Under that, you'll find a specific code for supply and install high-voltage cables.
So you basically just keep drilling down until you hit the actual physical object you're holding in your hand.
Precisely. You drop to level 6, which might specify whether it's a single-core 11 kV or a multi-core 11 kV cable. And then you go down to the absolute bottom, level 7.
Which is what?
This specifies the exact cross-section of the wire, like a massive 800 square millimeter cable. So the code to get paid for that one single piece of wire is this massive string of numbers tying all the way back to the master project definition.
Okay, I get it now. It's basically the project's DNA sequence.
I like that analogy.
Like every single nut, bolt, and tray has a unique genetic code, so there's zero ambiguity about what is actually being purchased.
Let's take that a step further, though, because knowing the code is actually only half the battle. What's crucial to understand is how this coding system interacts with something called the preambles.
Right, the preambles.
In a schedule of rates, the actual item description next to that long WBS code is kept incredibly brief on purpose.
Really? Why?
Well, it might just say, supply and install single-core 11 kV high-voltage cable. It doesn't give the contractor a 5-page essay on how to install it, but that brief description is legally bound by the preambles.
And the preambles are the ultimate rule book we are diving into today.
Yes. The text explicitly states that in the event of a conflict between the preamble and that brief description in the schedule of rates, the preamble takes precedence. It ensures that the short description actually encompasses everything necessary to carry out the work, regardless of difficulty, location, or complexity.
But I mean, why structure it like that? Why keep the description so incredibly short and then hide all the brutal rules in a preamble at the front of the book?
It's a good question.
Why not just write out exactly what you want the contractor to do right next to the code?
Because of bankability. Financiers and major clients won't fund a multi-billion-dollar project without absolute certainty regarding costs.
Okay.
If a contract lists out, say, 50 specific steps to install a cable, and the contractor encounters a necessary 51st step out in the field.
Oh, they'll just ask for more money.
Exactly. The contractor will file a claim for extra money. The preamble is a financial shield. It basically says, look, we aren't going to tell you how to do your job. You are the expert. But whatever it takes to get this cable functioning under whatever conditions you encounter is included in your single rate.
Wow. Okay, so it completely shifts the burden of figuring out the how onto the contractor.
100%.
If you are the builder, you'd better know exactly what goes into supply and install, which actually leads us right into section 3.6 of our sources, the specific electrical and instrumentation preambles.
This is where it gets really interesting.
Yeah, let's look at what actually happens when a contractor prices an electrical cable under these rules.
This is where the casual illusion of, just pulling a cable completely falls apart. Let's look at the measurement rule first. The preamble states that cables are measured strictly net in meters.
Net in meters.
Yes. That measurement is based purely on the actual installed and pulled length between the points of entry on the equipment boxes.
Wait, hold on a second. I need to stop you there.
Sure.
If I'm wiring my own house,
Right.
I go to the hardware store, I buy a spool of wire, and if it takes me a whole school to figure out the routing and make mistakes, I pay for the spool.
Right.
Are you telling me that if a contractor pulls 100 meters of heavy industrial cable from panel A to panel B, but they need, say, 5 extra meters coiled up inside the junction box as a tail so that their electricians can actually strip it, manipulate it, and connect it to the breakers?
Yes.
They only get paid for the 100 meters between the boxes. They just eat the cost of the extra wires sitting inside the panels.
That is exactly what the contract demands. The preambles strictly state that the cost of tails within the equipment and any overpulled length or waste must be included in the contractor's base rate for the installed net length.
That is wild. They literally have to buy wire they know they will never get paid for directly, and then try to hide that cost inside the per meter rate of the wire they do get paid for.
It forces a brutal level of precision on the estimators. The client is basically saying, I only want to pay for the literal distance between these two boxes. It is your job to predict how much extra tail your specific electricians will need, how much waste you'll generate from cutting, and bake that into your bid.
Let's talk about the cascading effect of that, because the text goes further into what's hidden in this supply and install rate.
Oh, it's a long list.
It isn't just the copper wire and the tails. The preamble lists out all the required actions. It includes measuring the routes, snaking and looping the cable, jacking the massive spools, pulling it into the trays, temporary tying, final fixing with cleats, and crucially, protecting the ends against damage and moisture before it's terminated.
And don't forget the consumables.
Right.
The preamble deems that your rate automatically includes cable cleats, ties, tags, markers, crimp rings, sealing compound, ground coating, lock nuts, heat shrink sleeves, and fire stop putty.
I mean, you cannot bill the client separately for a tube of fire stop putty.
No, absolutely not.
So imagine a scenario where a contractor's estimating team forgets to include the cost of a 50-cent heat shrink sleeve in their per meter bid. 50 cents sounds like absolutely nothing.
It does.
But if they're pulling 300 kilometers of control cable across an entire petrochemical plant, and that requires, what, 10,000 separate terminations?
They suddenly lost thousands of dollars on a tiny oversight, and there is no mechanism to ask for that money back. The contract prevents it entirely.
And we also need to appreciate the sheer physical scale of the materials we are dealing with here.
Definitely.
The schedules list low-voltage cables, starting from tiny 1 square millimeter single cores. But it scales all the way up to massive 630 square millimeter cables,
Which are huge.
We are talking about cables thicker than your arm, wrapped in heavy armor. Pulling these isn't like a couple of guys with a ladder. It requires heavy winches, significant manual labor, and massive cable trays that the schedules note can be up to 900 millimeters wide.
It is heavy, physically demanding industrial work. But what's fascinating is how the Red Book preambles handle the shift from that brute force heavy electrical work to the incredibly delicate work of the project's nervous system.
You're talking about the instrumentation section now.
Yes, the sources list highly specific instrumentation components. We aren't just talking about thick copper power cables anymore. The preambles cover everything from generator interfaces to gas detectors to vibration probes.
Yeah. And the fiber optics. The schedule specifically lists 10-micron fiber optic cables, ranging from 6-core all the way up to massive 96-core bundles. And the rules for installing these are a totally different ballgame.
The installation rates for instrumentation are fascinatingly strict. A 10-micron fiber optic core is incredibly fragile. We are essentially talking about microscopic glass mirrors transmitting light.
Right.
If you pull it too hard, it snaps. But more importantly, the preamble explicitly states the rate must include protection, including humidity control.
Which makes sense. If moisture gets into a 10-micron fiber optic connection, it ruins the reflection and effectively blinds the communication system of the plant.
Exactly. And beyond the environmental controls, the mechanical requirements are dense. If an instrument comes with delicate capillary tubes, the contractor must handle, assemble, and secure those tubes without kinking them.
And carefully coil and secure any surplus perfectly, I assume.
Yep. Drilling backplates and fabricating custom steel work for mounting these instruments is also deemed to be included in the single unit rate.
This feels like it's like pulling a power cable is like plumbing a water main, but installing a vibration probe on a generator is like performing brain surgery.
That's a great way to put it.
So, getting the instrument on the wall without breaking it is step one. But the most intense part of the instrumentation preamble seems to be the testing.
Oh, yes.
The rate isn't just for installing the device. The text explicitly says the rate includes pre-calibration, function testing of loop items, and loop check testing, all according to the vendor's specific recommendations.
That is perhaps the most critical transfer of risk in the entire E&I section.
Can we break down what a loop check actually means in this context? Because it sounds like they just checking a circuit, but I'm guessing it's much more involved than that.
A loop check is basically verifying the entire chain of communication. Let's say you install a highly sensitive gas detector out in the middle of a processing unit.
Okay.
A loop check means you don't just test if the detector turns on, you have to physically simulate a gas leak at the sensor.
Like actually spray gas at it.
Basically, yes. You verify that the sensor reads it accurately, watch that signal travel all the way back through those fiber optic cables to the main control room, and confirm that the specific alarm graphics pop up on the operator screen. You are testing the entire loop of the system.
And the contractor has to prove it works perfectly before they can consider the item installed and actually get paid for it.
Yes, because these instruments are the safety and operational eyes of the facility. A failing gas detector or a faulty vibration probe on a multi-million-dollar turbine isn't just an inconvenience.
It's a catastrophic safety hazard.
Exactly.
But what happens if it fails? What if the contractor runs that loop test and the signal just doesn't reach the control room?
Then the harsh reality of the preamble kicks in. The text notes that if an instrument fails calibration or a loop test, the contractor has to isolate the problem, reconnect it, readjust it, and recalibrate it.
Oh, man.
And they have to do all of that on their own dime, absorbing all those labor hours within that single original unit rate they bid years ago.
Wow. So there's no submitting a change order because the calibration turned out to be trickier than the manual suggested, or because a technician had to spend 3 days finding a bad fiber optic splice.
None whatsoever. By forcing the contractor to own the testing and the troubleshooting within the base unit rate, the preamble ensures there is absolutely no financial incentive to rush the installation or do sloppy work. If you do it poorly, you just pay your guys to do it twice.
That perfectly highlights the underlying logic of these documents.
Yes.
It's really about trapping the risk.
Yes.
Which brings us to the broader picture. Because the sources don't just have specific preambles for E&I. They include the general preambles, which apply to every single discipline on the project.
Right.
Looking at section 1.5, it details what they call the measured work composite rates. And this section is essentially the ironclad shield for the employer.
It's the ultimate safety net for the project's financiers. It defines that the rates entered by the contractor are deemed to be fully inclusive of overhead, profit, and all payroll burdens.
And payroll burdens is a loaded term here. It isn't just the hourly wage you pay an electrician.
Not at all.
The text explicitly says it includes bonuses, overtime, shift premiums, qualification payments, fares, travel expenses, labor insurances, levies, taxes, and pensions.
It sweeps up everything. It also mandates that the rates must include all scaffolding necessary to reach the work, temporary protective materials, and waste disposal, explicitly including the safe disposal of hazardous waste.
Let's talk about the materials side of the general preambles, too. Because going back to our discussion about the cable tails, there is a specific clause regarding the materials you buy.
Ah.
The preambles state that rates for materials are deemed to include an allowance for rolling margin, cutting margin, waste, surplus, and the like. I really want to focus on rolling margin because that is a fascinating contractual concept.
It really is. Rolling margin refers to the manufacturing tolerances at the factory level. If a manufacturer is producing massive spools of electrical cable or custom steel supports for cable trays, they might guarantee the length or weight to within a plus or minus 2% tolerance.
Meaning if you order exactly 1,000 meters of cable, the factory might send you 1,020 meters, or the steel might be slightly thicker and heavier than perfectly specified.
And you, the contractor, have to pay the factory for that actual produced amount. But the rolling margin clause in the preamble dictates that you cannot pass that factory variance cost onto the ultimate client.
You just have to absorb it.
Exactly. The client pays the net theoretical length installed. You eat the factory's margin.
That is incredibly tight. It sounds to me like bidding on one of these FIDI mega contracts is like booking a group at an all-inclusive vacation resort, except you are the hotel.
Okay, I see where you're going with this.
You have to guess exactly how many pina coladas the guests are going to drink 3 years from now. If they drink way more, or if the wholesale price of rum suddenly skyrockets, you just eat the cost. Your room rate is firm and fixed.
It's a great way to visualize the financial pressure, but let's add the engineering stakes to that analogy, because what happens when something actually breaks?
Right.
The general preambles have a clause that says the rates must include the cost of carrying out remedial work caused by the contractor's own mistakes or their method of working.
Right. So if you drop a highly sensitive control panel while installing it, you buy a new one, but you obviously only get paid to install it once.
Or consider the E&I specific risks. Let's say a contractor is installing a massive step-down transformer. During the installation, their crew accidentally damages a critical internal bushing, but they don't realize it until they energize the system during commissioning and blow a relay.
Oh, that sounds expensive.
It is. The contractor is on the hook for replacing the blown relay, repairing the transformer, retesting the system, and managing the hazardous waste disposal of any leaked insulating oil.
And the preamble dictates that every single hour of that nightmare is deemed to be covered by their original base unit rate?
Yes. And if the scope of work changes slightly or the schedule is extended, the text explicitly says no extra money is given for loss of overheads or profit. The rates are firm and fixed.
Incredible.
A contractor who doesn't deeply understand these preambles will look at the brief description, say, supply and install 100 meters of 11 kV cable, and they will bid low, thinking only about the wholesale cost of the copper and the raw hours to pull it.
And they'll probably win the job because their bid looks incredibly cheap to the client.
But then they will go bankrupt, because halfway through the project, they will realize they have to pay for their own complex loop check recalibrations, build their own complex scaffolding just to reach the cable trays, and absorb all the waste of the cable tails. If you didn't bake those invisible E&I risks into your all-inclusive rate on day one, the contract will simply bleed you dry.
It is a ruthless environment.
Yeah.
But when you are building something that costs billions of dollars and powers entire cities, I suppose the paperwork has to be as bulletproof as the concrete.
It really does.
The banks need to know the bottom line.
The contract is the ultimate structural foundation of the project. If the contract is ambiguous, the project finances will collapse, no matter how brilliant the actual engineering is.
So to wrap this up for you, our listener, the next time you drive past a massive power plant, a sprawling petrochemical factory, or really any piece of heavy infrastructure, remember that the physical world around you is held together by more than just steel columns and massive 630-millimeter high-voltage cables.
There's a lot more holding it up.
Yeah, it is held together by the invisible, ironclad legal logic of documents like the FIDIC Red Book preambles. Every single zip tie, every fragile 10-micron fiber optic thread, and every dab of fire stop putty was accounted for, projected, coded, and costed long before a single shovel ever hit the dirt.
It requires a level of human organization and foresight that is genuinely remarkable to study.
It really is. But it leaves me with one final thought, something for you to mull over after we wrap up here today. We've seen how these Red Book preambles force human contractors to predict the future, to account for every millimeter of wire, every potential loop testing failure, and every fluctuation in factory rolling margins. It makes you wonder, as our technology gets exponentially more complex and these physical mega projects rely more heavily on hypersensitive AI, automated smart instruments, and robotics, will human estimators even be capable of predicting all these invisible risks? Or will these massive legal contracts eventually become so densely complex with so many cascading variables that only an AI can effectively negotiate and bid on them? Till next time, keep diving deep.
If you're interested in the templates, please visit our shop. The link is in the description.
Thanks for watching. Please subscribe and see next time.